Let's face it, working with assemblies can be challenging. Even seemingly simple products can be made up of complicated assemblies. How well does your team manage assemblies with relationships and interdependencies between components? Are team members able to collaborate effectively on a single product? Fortunately, Creo provides a set of advanced assembly tools for top-down design and concurrent engineering. Top-down design is a methodology for managing the design of large, complex assemblies by consolidating critical information that affects multiple systems and components, and then distributing that information to lower levels. Like the name implies, rather than starting with individual parts, first you create the top-level assembly. You can lay out the product structure. Using component creation tools, you can create subassemblies and parts. Essentially, we're building our bill of materials up front. Defining the product structure early helps you plan the team's tasks, the CAD equivalent of a work breakdown structure. To manage the interdependencies for geometry in a complex product, we can use a model called a skeleton. It contains important surfaces and datums to be referenced by other components. Skeletons can also be used to plan mechanisms. Now we need to share geometry from our skeletons to other components. To help identify the geometry that other components and designers will need, we can use a publish geometry feature. A publish geometry feature consolidates the bodies, surfaces, and other geometry that a different model might want to reference. A copy geometry feature can then copy that published geometry feature into another model. The copy geometry feature can also manually copy bodies, surfaces, curves, edge chains, datums, and 3D annotations from a source model to a target model. A merge feature is the Boolean addition, subtraction, or intersection of all the geometry from one model to another. An inheritance feature is a one-way associative merge of all the features from one component to another component. However, this feature allows you to change dimensions, features, parameters, and more from the source model, while everything else remains dependent. A shrink wrap feature allows you to grab surfaces from any or all of the components in an assembly. This is especially useful for copying references for routing cables and pipes. Data sharing features are preferable to making external references directly to another model because you can control how the target model updates with changes to the source model. For example, you most likely don't want the target model updating after the source model has been released to manufacturing. By sharing data from a source model, you can populate another model with its necessary features. Notebooks allow you to capture the important dimensions and parameters that you want to control for multiple components in an assembly. You can connect parts and assemblies to the notebook by declaring the model to the notebook. Changes to the notebook are propagated to the models declared to it. Notebooks are another way in which we control our assembly and its components at the top level. Now that critical geometry and parameters have been shared to parts, we can create the necessary features. All of these data tools help manage and communicate information with the design team. The lead designer identifies the information each team member needs to develop their subassembly without surprising other team members. Top-down design tools like skeletons, data sharing features, and notebooks can be used at all assembly levels to provide you with the right balance of control, creativity, and speed for development of complex products. For more information about concurrent design, visit ptc.com/Creo today.